Back everyone. In this lecture, we're going to be talking about the paired samples t-test, otherwise known as the dependent samples t-test, simply the paired t-test, the correlated samples t-test. It goes by quite a few names. I typically refer to it as the paired samples t-test. So what we're going to cover is when to use it. We're going to focus on something called difference scores, which play an integral part of the paired t-test. Then we're going to go through a hypothesis testing example, and then I will finish up with a couple other examples you can walk through on your own. The reading for this particular lecture is Chapter 6, Module 12 from the 4th edition of your course textbook. Let's go ahead and get started. Next slide. So as we were doing with all of our inferential tests, we're going to start off with trying to understand when would I use a paired t-test. And so the first thing we want to look at is this under when to use. We can read right here, use to compare two samples when you have observations in one sample that can be paired with observations in the second sample. That's the key phrase there, bolded. Observations that can be paired between the two samples. As you may recall from previous lectures, all t-tests focus on comparing two different groups. When we did the independent samples t-test, the focus was on comparing two independent groups. But when we violate that assumption of independence, so there is some sort of correlation or dependence or association between the two groups, we need to use an alternative t-test. That's where the paired t-test comes in. There's several different versions of the paired t-test. We are going to be talking about two of those versions this semester. So let's take a look at the first one. The first version of the paired t-test that we will look at, and arguably one of the most useful versions of the paired t-test, is what is known as a repeated measures test. So a repeated measures test enables us to see whether or not there is a change in some sort of dependent variable from before participation in something versus after. So if you may recall from a research methods class, a classic experimental design often has a group of individuals selected. They get a baseline measurement on some sort of outcome. Then they get, quote unquote, the drug or the program or the pill, or they get some sort of intervention. That is the independent variable. And then they have their outcome measured at the end to see whether or not there's a change in it. So that's the notion of how repeated measures work. So and the key thing here is that both the pre and post-test observations must come from the same subject. So let's look at an example. The first example is here in blue. Imagine we had students who were in high school and were getting ready to take the SAT test before they sent out their college applications. That maybe they choose to enroll in some sort of SAT preparation course. Well, in order to see whether or not that SAT preparation course is effective in educating them, we might design a study where students come in, they are measured on an SAT score as a pre-test, then they go through several weeks of this SAT preparation course. That becomes the independent variable. And then they are measured once again at the end as a post-test on another SAT test. And the question is has their SAT score changed from pre to post? A second example of this would be looking down under B in the red. We may design something where we're trying to assess a change in level of aggression for individuals who are on probation who have been assigned to an anger management program. Once again, if we want to know whether or not that anger management program is effective at all, we may do a baseline pre-test measurement of their level of aggression, send them through the anger management program, and then after they complete it, measure their level of aggression again. And once again, the focus of analysis is looking to see, do we see a change in their level of aggression? So in both of these, both the SAT example as well as the anger management example, you'll notice that the independent variable is sort of the intervention. It's the thing that we throw into it, the experimental idea that is introduced to these individuals. The dependent variable is this continuous outcome variable that we measure at 2 points in time. So the key points to take away so far with the repeated measures is, number one, the dependent variable must be at a quantitative or continuous level. So it's got to be at that interval or ratio level of measurement. And so you'll notice in both the blue as well as the red examples, the dependent variable SAT score would be at that interval or ratio level of measurement. And then with the red example, with the anger management, level of aggression, it's not stated on this slide, but we would assume that it has to be measured in some sort of continuous fashion. So maybe like on some sort of scale that is measured at an interval or ratio level of measurement. So the dependent variable must be measured in a quantitative or continuous manner. And the second thing that is key about a paired t-test is that the exact same group of subjects are measured at each time point, at the pre-test as well as at the post-test. It's not two different groups, it's the exact same group of subjects. Let's go ahead and move on to the next slide and take a look at another use of the paired t-test. So a second application of the paired t-test is when we are going to be doing a comparison of two different methods of measurement or treatment that is applied to the same subjects. So once again, you're noticing this idea of the same subjects being measured on two different things. So in this example, let's look at the first example, the blue one. We may have a research question that says, is there a significant difference in the readings from two alcohol level assessments? So you may be in law enforcement and you're trying to figure out what is the effectiveness of different forms of alcohol level assessment when you're doing roadside stops or whether it's back at the station. And we may want to know, do we see similar findings or do we see different findings when we have two types of measurements? So in this example, you can imagine that the first measurement that is given to the subjects would be the BAC, a blood alcohol level test. And then you want to also compare that versus the breathalyzer test as measurement 2. In both cases, the exact same set of subjects would receive both measurements, and then you would conduct a paired t-test to see whether or not there's an association between those two different types of measurement or whether or not they are significantly different from one another. In the second example, and actually we're going to see this as one of our examples at the very end of this particular lecture. So example 2, is there a significant difference in how an individual will be willing to intervene when witnessing a domestic violence situation? So this comes from some research that I did with a graduate student a few years ago, where we wanted to know if somebody's witnessing a domestic violence encounter, whether it's somebody that they know, whether it's out in public, that's not the point that we're care about right now, but they witness something. Will people intervene and try to stop that sort of domestic violence incident? And then she raised the question, the grad student raised the question, is there a difference? Are some people more likely to directly intervene or indirectly intervene? So directly intervene would mean to, like, if they're fighting, get in there and break it up or confront the perpetrator. Indirectly would be, do they tell somebody about it? Do they call the cops? Do they report it? Something along those lines. And we wanted to know, is there a significant difference in people's willingness to intervene? And we wanted to measure these two intervention styles. So in this case, measurement 1, willingness to directly intervene, was given to a group of subjects. And then measurement 2, willingness to indirectly intervene, was given to that exact same group of subjects. And then we conducted a paired t-test to see whether or not there was similarities or differences in how people responded when witnessing a domestic violence situation. So the key takeaways for this one is, once again, you'll notice here that we don't really identify an independent or dependent variable in this type of paired t-test. Rather, we just call them measurement 1 and measurement 2. But the key thing is that those measurements that we're going to compare still have to be measured at that quantitative level, that interval ratio level of measurements. And then number 2, as I've said several times, the exact same group of subjects are measured on both measurements. That is a key thing of the paired t-test. You have to have paired samples or paired groups. All right, let's go ahead and move on to the next slide. At the beginning of this lecture, I talked about the importance of difference scores, and difference scores are sort of the backbone of what makes a paired t-test unique and different from the independent samples t-test. Now we could go into how the difference scores play a role in how we measure variability and how we compute the t-statistic and things of that nature, but we'll save that for another day. Right now, I'd rather have you just understand the importance of difference scores for a paired t-test. So let's take a look at the writing in blue here. When we did the independent samples t-test, that was focused on examining differences between the means of two independent groups. We assumed that people in group one, maybe that was the male group, were independent and had no influence on group two. Maybe that's the female group. Right? So, or maybe we have property offenders and violent offenders, but those two groups in an independent samples t-test are independent from one another and should have no influence on each other. The paired t-test, though, the statistical behind the scenes work assumes that there is an association between the two quote unquote groups. So the paired t-test focuses on examining difference between paired observations from the same subjects on two different measurements. Those two different measurements can be a pre-test and a post-test, as we saw with the SAT example, or they can be two different measurements like we saw with direct versus indirect intervention in a domestic violence situation. But the key thing here is each observation in group one has to have a pair in group two, so then we can compute what is known as a difference score. So let's go ahead and take a look at an example of how that works. So let's move on to the next slide. So on this slide, let's imagine that a researcher was curious whether or not people changed their sleeping habits as they got older. Right? I mean, when you were in high school, were you sleeping more? Were you sleeping less? Now that you're in college, do you feel like you have more time to sleep, less time to sleep? Once you're out of college and you're out working full time, how do things change? So let's say if somebody wanted to study that simple question, do people change their sleeping habits as they get older? Let's just take a look without any fancy numbers, but just the concept of difference scores. So down in the table, imagine we have 6 subjects, 6 people that volunteer for this study. We first contact these individuals at age 16, and we get a measurement of the typical number of hours they sleep each night. And so you'll notice subject 1 sleeps 8 hours on average, subject 2 sleeps 7 hours on average, subject 3 sleeps 8 hours on average, etc. Right? So we have all of that. Then 10 years later, we follow up with the exact same group of subjects. So this is a longitudinal design, once again, to bring up another research methods concept that you probably have heard about. So we're following the exact same group of people to say, do we see changes over time in this longitudinal study? So at time 2, we try to contact the exact same 6 people. Person number 1 now sleeps only 7 hours a week, or 7 hours each night. Person 2 still sleeps 7 hours. Person 3 sleeps 9 hours, and so forth. You'll notice, though, and this is one of the tough things about longitudinal designs and paired t-tests, is look at person number 5. Subject 5, we have a time 1 measurement. At age 16, we know that they slept 8 hours each night. However, they weren't available for follow-up at age 26. It's been 10 years, right? So maybe they chose not to participate in the study anymore. Maybe they've moved. Maybe they're unable to get a hold of them. Maybe something else has happened to them. So we don't have the opportunity to have that second measurement. This is one of the tough things with the paired t-test because we need to have complete pairs in order to conduct our study. So let's look to the circled in red right-hand column, the difference score. This is where the focus of a t-test or a paired t-test takes place. It's not comparing age 16 to age 26 as if they're independent. No. Rather, it is focusing solely on that difference score column. So each pair gets a difference score. So like person number 1, as we look at their change in sleep, they have decreased their amount of sleep by 1 hour per night. Person 2 is sleeping roughly the same, so there's no difference. Person number 3 is sleeping an hour more each night, and so forth. You'll notice once again that for person 5, because we don't have measurements at both time points, we can't compute a difference score for person 5. So we would actually have to remove them from our study. So when it comes to research methods and methodological issues, that can be a problem about our validity of our findings, because we don't know, is there something unique about the people that we lose over the course of a longitudinal study. But statistically, we would just have to admit it and say, even though we started with 6 subjects, we only ended up with 5 matched pairs, and therefore our paired t-test focuses only on that sample of 5. So looking at those difference scores, what we're going to see in our hypothesis test is the hypothesis, or the hypothesis test is going to be examining not whether or not if mean from age 16 is equal to the mean from age 26. Rather, it's going to be saying, is the mean for the difference score significantly different from 0? So when we get to the null and alternative hypotheses in step 2 of our hypothesis test, you'll see that reflected in how we change the way we write our null and alternative hypotheses. The focus will be looking at that difference score and the average difference score for the overall group. All right, let's go ahead and move on to the next step and get started with the hypothesis test. Once again, you've seen this on a few different lectures now. It should be somewhat familiar. We have our 6 basic steps of our hypothesis test. We start with the statement of our research question, followed by setting up our null and alternative or research hypotheses. We set alpha. We talk about the critical value. We then have to figure out our observed value of the t-statistic, and then we make our decision, reject or fail to reject the null hypothesis. So let's go ahead and get started. Next slide. Once again, as we saw with the independent samples t-test, we have access to SPSS Output, right? So it has everything we need here. We're not going to have to hand compute anything, but just like we saw with the independent t-test, we're going to have to know what information to pull, what to look at. So let's take a quick look at this output before we launch into our hypothesis test. And so reading from the top, this is a paired t-test example examining differences in drug cravings that's measured in a continuous fashion before and after participation in a 90-day rehabilitation program. So in this case, thinking back to the examples that we started with, this would be one of those pre-test, post-test, repeated measures applications of the paired t-test. The independent variable is participation in this rehabilitation program. But in order for us to see whether or not participation in the program has a significant influence on your drug cravings, we need to have a baseline or a pre-test measurement of your drug cravings. That's the before measurement. Then you go through your 90-day rehabilitation program, and we compare your pre-test of drug cravings to a post-test. And after you finish the program, we measure your drug cravings again, and then we compare the before measurement to the after measurement. So what you'll see here, and we'll go see this in a little bit more detail in the next slide, we have our paired samples statistics box. That is the information about our samples. So you'll notice here, it says nothing about the 90-day rehabilitation program. It's not mentioned on the output. So the independent variable is not going to show up here. But what we do see is it talks about the craving, right? That's our continuous scale of your drug craving levels. And what we're looking at is the before compared to the after. So looking at that paired sample statistics box, you'll notice looking at the mean column, that is for the sample, the average drug cravings at the 2 time points. And it appears that people had higher levels of drug cravings in the before measurement than they did in the after, right? The before had 35.57 as a mean, whereas the after, it had dropped down to 26.33. So just like we've done with other hypothesis tests, we see a difference there, right? We see a reduction in drug cravings, but this is sample data. We still have to figure out, can we use this and infer that the same thing would hold true in the population? Is there truly a significant difference in drug cravings in the before versus after measurements? So that's what we're going to be doing. The next column in that paired sample statistics box is the N. So once again, this is the sample size. And you'll notice anytime you're doing a paired t-test, the N will be the exact same number at both time points for both the before and the after. Why is the N the exact same number? Because it's the exact same people. The same 21 people who we got a measurement for before are the same 21 people that we collected a measurement at the after time. Those are our 21 pairs that are being, part of our overall sample. Then we have the standard deviation, the standard error of the mean. For the sake of this course, we're not going to be worrying about that. Let's quickly look down at the middle box. The middle box on this output says paired samples correlations. For the sake of this course, you will never be asked to pull anything from that box. So don't allow yourself to get pulled into it by looking at the sig and thinking that's the p-value you need to report. No, we're not worried about the paired samples correlations. The reason why it's there on the SPSS output, however, is so that a researcher can figure out whether or not there is some level of correlation between time 1 and time 2, or the two groups that you're looking at. And because a paired t-test assumes some amount of correlation, you don't want that correlation to be 0. And if you're going, what do you mean by the correlation? That correlation that you see in that box of negative 0.159, that's just an R value. You may recall from Pearson's R when we talked about correlations earlier in this semester, that's all that is. So it's saying, yeah, there's a negative correlation between the before and the after. That's it. And then it has its own sig to see whether or not it is a significant correlation. But once again, we're not going to worry about that. So paired samples correlation box, you can put an X through it mentally, at least for this semester. We're not going to be focused on it. Finally, down at the very bottom box, we see the paired samples test box. This is where all of our action happens. This is where we're actually going to get our observed t statistics, as well as the p-value, the confidence interval, and find out whether or not we can reject or fail to reject the null hypothesis. The nice thing about a paired t-test is you'll notice there's only one row of data. It's not like the independent samples t-test where we had to do the Levines and figure out homogeneity of variances or any of that sort of assumptions. Paired samples, we don't have to worry about that. So that makes it kind of nice for us. So let's go ahead and take this hypothesis test and walk through the actual steps and see what we get. Let's move on to the next slide. So as with all of our other hypothesis tests, we start with step 1, statement of the research question. So we ask, does participation in a 90-day rehabilitation program significantly change drug craving levels? So we look at our paired sample statistics, and I went over this a little bit on the previous slide. But once again, it gives us an idea. We have the before versus the after. We see that before, their drug craving levels on that 50-point continuous scale was about 35.57. After participation in the 90-day rehabilitation program, the average drug craving drops down to 26.33. We know that our overall sample size was 21 people. That's why there's 21 at before, 21 after. It gives us 21 pairs that will be part of the t-test, and we can move forward with it. So let's go ahead and move on to the next slide. All right, step 2, statistical hypotheses. This is also one of the nice things about a paired t-test is what you see on this slide is what you will write for your statistical hypotheses. It never changes. Why? Because it is examining difference scores. So let's get the null hypothesis. The null hypothesis says the mu of D equals 0. So that's saying that in the population, if there's no difference after participation in the 90-day program, that the difference between the before and after scores would be equal to 0. So there is no difference in the level of drug cravings before versus after program participation. And this is what I referred to a few slides ago. You may recall I said, well, if you contrast this with the independent samples t-test, where we had the mu of group 1 equals the mu of group 2. We don't have that in a paired t-test because our focus is not on two independent groups. Rather, our focus is on difference scores. And that goes back, remember that difference scores column that I had with a sleeping example a few slides prior. We move down to the alternative or research hypothesis. Now it's simply that the mu of D does not equal 0. So that would infer that, or that would conclude that there is a difference in the level of drug cravings before versus after program participation. And I make a note down at the bottom here. Even though this particular example does talk about drug cravings, that D does not stand for drug, it stands for difference. So no matter what paired t-test you're doing, the statistical hypotheses will look just like what you see on this slide. All right, let's go ahead and move on to our next step. Next slide. Alpha, level of significance, we're setting it at 0.05, just like we've done and just like we will continue to do. Not much to talk about on this one. Let's move on to the next slide. Critical value. Also, something that we're going to be able to skip through pretty quickly nowadays, because just like we learned with the independent samples t-test, we now have access to there's a misspelling there, that's my fault, SPSS output, so we do not need to look up the critical value on a chart. Instead, we will use the p-value for the observed t-statistic to make our final decision in step 6. So we don't have to worry about looking up or recording a critical value. We can move right on to finding our observed value in step 5. So let's move on to the next slide. Also, this is another nice thing about the paired t-test. As I mentioned previously, we don't have to do the fork in the road, Levine's test, or any of that stuff. We just go straight to finding our observed t-statistic. And you'll notice in the paired samples test box where you will find this information on your output, you'll see that there's only one row of information. And so therefore, when it comes to finding our observed t-statistic, you don't have to compute anything, you just have to find it. So you'll see the red arrows pointing to that t-statistic of 3.112. So you'll want to make sure that you're able to report that. But also, as we learned from our previous t-test, now that we're working with t-test and other tests based primarily on samples, we also want to make sure we report our degrees of freedom. Remember, the degrees of freedom is very closely related to sample size. For the paired t-test, the way that it's computed is it's the number of pairs minus 1. So you may recall from the previous slide, we had 20, our n, our sample size was 21. So we had 21 pairs minus 1, and that's why we see that degrees of freedom of 20. But once again, whether or not you remember that right now is not as important as being able to find it on the output so you can report it in your results. So we have a T of 3.112. We have a degrees of freedom of 20. Now we can move on to finally step 6 and make our decision. Let's move on to the next slide. So in step 6, we get to make our test decision of either rejecting the null hypothesis or failing to reject the null hypothesis. Now, just like we saw with the independent samples t-test, there are two things we can look at on our output to make that decision. Now, the gold standard is always going to be the p-value for the observed t-statistic. And as I mentioned before, just like with the independent samples t-test, for the paired samples t-test, you can find that p-value for the observed t-statistic by looking at the sig two-tailed column. And you'll see that I've got it marked in blue. The sig two-tailed gives us a value of 0.005. So we have a p equal to 0.005. And then we can use our breakdown of it that's in black in the middle of the slide to make our decision. If p is less than 0.05, we can reject the null hypothesis. And then on the other side of it, if p is greater than 0.05, we would fail to reject the null hypothesis. So take a moment, look at it. P equals 0.005 is in fact less than 0.05, so we're going to reject the null hypothesis. And a second thing we can look at to figure out to make sure we made the right decision is the confidence interval, the 95% confidence interval of the difference. You'll notice here it has a lower and upper bound, just like we've seen with other confidence intervals, and it starts at a positive 3.04527, and then it runs up to a positive 15.43092. And the reason why I just stressed positive 3 point, etc., and positive 15 is because on a number line, the confidence interval starts at a positive value and ends at a positive value. So the key thing that does not exist within this interval is 0. 0, which is the null value, right? When we looked at the null hypothesis back in step 2, it was mu d equals 0. 0 is not possible. Therefore, we can reject the null hypothesis. So both the fact that our p-value is less than 0.05 and the fact that the confidence interval does not include 0 allows us to reject the null hypothesis. Let's go ahead and move on to the next slide for some interpretations of our findings. So in this particular hypothesis test, we ended up rejecting the null hypothesis. And our presentation of findings is similar to what we learned in our last lecture about the independent samples t-test. We can always write it up in a nice clean way by showing the statistic, t, then in parentheses the degrees of freedom, 20. Then we have in green the value of the observed t statistic, 3.112. And then we finish off with the p-value for the observed t statistic of 0.005. And down at the bottom, we could write this up with something along the lines of, based upon the results of a paired t-test, we can conclude there is a significant change in the levels of drug cravings after participation in a rehabilitation program, with subjects showing lower levels after the 90-day program. And then we just plug in that nice little bit of information to summarize the type of test we did, information about the degrees of freedom, and our overall findings. That, everyone, is a paired t-test. The next couple slides are going to give you a couple more examples. I'll go through them and just sort of say one or two words, but use those as sort of an opportunity to practice and look at the output, walk through the steps yourself, and see if you get the same conclusion that we're going to see on the conclusion slides. So let's go ahead and take a look at those real quick. In this example, we're looking at whether or not there are changes in alcohol consumption for college students between freshman and senior year. So this is also a repeated measures paired t-test, similar to the one we just walked through. And you can walk through it yourself and then see if you get the same conclusions that we'll see on the next slide. So I'm going to jump to the next slide. We can see our conclusions, see if you agree, and then we'll move on to one more example. So let's go ahead and take a look at the final example. Next slide. This one is also a paired t-test, but the only difference here, this is not a repeated measures paired t-test. This is that second type of paired t-test that I spoke about at the very beginning of this lecture. This is where you're examining measurements for the exact same group of people, but two different measurements. And this is real data from, as I said before, one of our grad students who had conducted a study examining willingness to intervene in domestic violence or intimate partner violence situation. And in designing her survey, she measured direct intervention versus indirect intervention. And they're both measured in a continuous fashion. And as you can see, we have a direct involvement scale and we have an indirect involvement scale. But the overall way that we go about interpreting it is going to be just like we did with the repeated measures examples that we saw before. So take a look at this one, pause this, do what you like, and then move on to the next slide where you can see the final outcome. Next slide. And here we have the conclusion for this one. See if your results agree. And then once you've got that, you are ready to go out there and conduct and analyze paired t-test. And that's it for this lecture. Take care.